Klung? Ha, worked. Well, hello to our first IG Data Fabric session, the first IG Data Fabric session in a fully organized RDA plenary that has been organized by Secretariat and the organizational members. And well, and we hope that the next time we organize our event, it will be a hybrid event, or we will meet in Seoul or somewhere else in person again. Well, today in our session, we will talk about fair digital object use cases and success stories. And for that, I'm now trying to share my slides. Where are they? Here we are. So, and I think everybody of you can now see our slides. Also, I would like to ask you, we have the collaborative notes, and the link to the collaborative notes you will find in the chat. Please sign into the collaborative notes. And the collaborative notes in the session we will also use as a kind as working notes. It's just not only to use them as notes, but also to work on them. Good. What is our plan for today? This is our agenda. So we will have here the link of the collaborative notes. First of all, I will give for the newcomers in here a short introduction of our interest group. Do we have any newcomers here? Please just show yourself.
Me, for example.
Ah, hi, yeah, thanks a lot. We will give a very short introduction to the IG. Then Christine will give a short overview, 10 minutes or something like that, on high-level views on fair digital objects, what this session is about. After that, we will go into the use cases and success stories, and we have collected a couple of teasers for them. And here on the right-hand side, you will see a couple of things we will see later and the persons who will present them. And then we will collect another idea, a couple of ideas, which kind of use cases and demonstration cases we would like to have. Okay, so let's start in that. We will have also lots of discussions, I hope. So, but first I would like to give a short introduction of our interest group. And then we will ask Christine to share her slides for the high-level views, and then we will start the first discussion. Okay, the IG Data Fabric was one of the first interest groups in RDA. The current co-chairs are Lori, oh, sorry, this is something I need to pronounce, Xing Shen, Rob Quick, and I, Rainer Stotzka. Welcome to our session. When we started this IG, this was, I think, in 2013 and 2014, the views on the data fabric was meant as a kind of tissue connecting all the services together. So how to connect these disparate components for being made to work together. Now, in our nowadays views, we have seen that this disparate is maybe not so necessary anymore. And we moved our topics more to the direction, into the direction of fair digital objects. And Christine, in a couple of minutes, will give an overview on these fair digital objects. Since we have changed a bit our focus from these disparate components and how to connect them to now a kind of a solution, we also updated our charter. We just did it. The reason for that is that we also would like to change the name of our interest group from the data fabric, which is a bit abstract, to the IG Fair Digital Object Fabric. So we are talking about in future how we can connect, how we can connect the services to serve the idea of the fair digital object concept. Our case statement currently, it's not a case statement, it's a charter. Our charter currently is in community review. You see here the link, and also you will find the link in the collaborative notes. What the new or the renamed interest group is about. We are meant to be a kind of a coordination and communication platform to share showcases demonstrating the usefulness of fair digital objects. This is exactly also the things what we are talking about today, to discuss implementation experiences, to build a platform for developers and software developers and service developers to communicate, to bridge with the work in the Fair Digital Object Forum, and Christine will give a link to that. And maybe also to create formal outputs in RDA working groups, focusing on specific problems on fair digital objects. Well, how do we operate for the newcomers in here? So we are a coordination and communication platform. Here we have also a kind of a website in the RDA wiki. Here we can find more information. So how do we operate? We have regular meetings. We have monthly meetings on every fourth Thursday on the month. And here we do discussions, working meetings, but most of our meetings are project shares. We ask somebody to share their experience on a project, how they would like and how they implement fair digital objects. All these project presentations are also being recorded, and the slides are available, and you will find them on our meetings page. And the meetings page and the link to the meeting page is exactly also where the slides which we are showing in here are also available, and you will find the link on that also in the notes. Then we are collecting information about fair digital object publications, RDA recommendations and outputs that are somehow linked to the concept of fair digital objects, components, workshops, and so on. And of course, we organize plenary sessions. Well, more or less, that's it. That's what we are currently working with. As a short introduction to our group. And before going into the discussion, I would like to ask Christine to give us a high-level view on the fair digital objects.
Happy to. Okay, well, I'm ready to share my slides if that's okay. Okay.
Great, we see it.
Okay, super. Well, good evening or good morning. It's probably only evening if anyone's in Hawaii or like me on the west coast of the US. Thank you all for tuning in. As Rainier introduced me, I'm Christine Kirkpatrick. I'm from the San Diego Supercomputer Center. I'm also part of the RDA tab. My term's just ending this month. And I'm also here representing the FDO Forum as one of the co-chairs. So many of you have been involved in RDA for quite some time, and you're thought leaders in research data management. This is why we come to these plenaries, to learn from each other. But for those of you who are not yet following or working yet with fair digital objects, you might wonder, well, what gap is this filling that isn't already solved by something somebody else is already working on? So many of us are working on trying to make sure that tomorrow's data is generated with appropriate metadata, PIDs, provenance, clear licensing, and examples of how to use it. But I've pondered for a long time, and I think many of you work on this problem. What do we do about data that's not born fair? So fair digital objects give us an approach that we can use to, if you will, retrofit existing data without touching it. And as well, it can sometimes be a challenge to store metadata alongside data and to keep it organized and ensure that everything stays together, at least in a way that could be machine actionable or that you could put together if needed. This is a basic definition of an FDO. Several of us are working on a publication that will provide more detail. And along the way, we've wrestled with several metaphors, such as, is an FDO like a cube or a Rubik's Cube? Is it like a file box? Is it easier to understand if you look at examples in practice, such as a single tweet, which is actually an example of a fair digital object? It can seem like each different definition is describing a different part of the elephant, and they're all correct. And maybe you want to step back and see what the whole picture looks like. And you saw a small version of this on Rayner's slides. This is a graphic from a wonderful paper, if you're interested, from Ulrich Schwartzman that just published last year. And I think this kind of wraps it up for me. FDOs are both a concept and a set of technical implementations that seek to solve the issues that I described on the last slide. Basic idea is that there's several layers of meaning that together make up that digital object. They're put together by a master object that knows how to find the bit sequence and the metadata. And bit sequence here could be a picture, software, an algorithm, a model, or again, just a tweet. And it's a departure from techniques like linked data a bit, which are more about embedding metadata in the data. Each of these layers has assigned identifiers to each thing, and they reference the master object that knows how to put it all together. Now, with my apologies to my colleagues who this is their area of research, because this is a ridiculously short history of fair data objects, but I am trying to stick to time. So just a couple highlights here. We see the term digital objects, of course, used before the 1990s in other contexts, but really in the context that we're talking about, it first appeared in the 90s, prior related to digital object identifiers, but people started to talk about this is a concept. And one of the earliest papers that we recommend on our Fair Digital Object Forum is this 2006 paper. Kind of gives starts off a bit of the literature on the subject. Well, over the last 5 to 6 years, which sounds like a short time, but that's of course a long time in internet years, we've had some great things come about. One of them is the concept of DOIP, which is similar to the concept of TCP/IP, gives a way for you to pass back information about digital objects. And there's also technical implementations for giving out handles and for communicating about the types of the different digital objects. Something important happened just a couple years ago. We refer to it as the Paris meeting that was organized by this group here. And this is really where the idea came from that we need to get together and have a forum on this topic. That's also where I believe Luis Bonino debuted his Fair Digital Object Framework, which is also wonderful, and I encourage you to check it out. This all culminated in the formation of the Fair Digital Object Forum earlier this year, just, I guess, 11 months ago. Does it very short time. And it's, I'm one of the co-chairs along with Peter Wittenberg, who's with us today, George Strawn, who's probably asleep, he's on the East Coast, and Demetrius Kourias, who you'll know from RDA Tab and other roles in RDA. And also, if you are interested in hearing more about it, several people are here today representing our steering committee, not just Rayner, but also I saw Carlos Wolf, Jonathan Clark, and Peter Muchke, and maybe others have signed in as I started talking. Now, of course, the Fair Digital Object Forum is a place that we meet, but it's not yet another thing. And we've thought very carefully, and thank you, Rayner and Bonnie Carroll, for developing this diagram, where we looked at the data together landscape, right? These 4 key data consortia that most of us belong to and take part in. And we see this Fair Digital Object Forum as kind of fitting as a core activity. And so all that to say, what we do here in this interest group is very key and will be brought back to the Fair Digital Object Forum and vice versa. If you'd like to know more about the Fair Digital Object Forum, I encourage you to go to our website, which is fairdo.org. And there are several working groups that are underway doing specific things. Here are the 5 main ones, and we just added a 6th that is working on how to fair implementation profiles. How do they work with fair digital objects? And that one is chaired by Eric Schultes. We have some upcoming events. We just completed our first community information meeting, and the recording is online if you're interested. We also presented at SciDataCon, and I believe that recording is online. Today, of course, we're excited to be here at RDA. There's this, it probably looks tiny on your screen, but this register link will take you to register for this other high level view of FDOs, even a higher level, very conceptual, and it should be a very fun event that my colleagues have put together on January 19th. Then look for us in the spring for another community information meeting where we'd really like to hear from you on how things are evolving, what challenges you're having, what you think about the publications or implementation examples we've put out. And then we're very optimistic that we will all be together in Leiden in October of 2022, starting on the 24th. And Leiden was chosen because it's the European City of Science next year, and there'll be some other co-located events. So with that, let me stop sharing my screen and hand it back to you, Rainer.
Christine, thank you very much for this great introduction of the Fair Digital Object and the Fair Digital Object Forum. We are now open for discussions. Please raise your hands if you have any questions, any comments. So maybe I might give a certain question or a kind of a comment, Christine. We have, on one hand, we have the FDO forum, and we have all this data together landscape. By the way, just to correct, I didn't create, and Bonnie and we didn't create this image. This has been created by Data Together.
Yes, sorry.
No,
it was the one in the bottom right, yes.
Yeah. The question is, how do we interact with the FDO forum and RDA, especially with our interest group? Okay, we have an overlap in persons. Do we need a kind of formal connection?
Well, I guess maybe I'd just like to put a strong point on it that RDA is where the community assembles. And so this is a very important interest group to the FDO forum for getting input, for bringing things in, and hopefully also for publishing recommendations. I mean, of course, you were a great link to both, Rainer, yourself, but I put it back to you if you feel like there are more formal ways, you know, updates perhaps, maybe a couple times a year, or at plenaries like this, whatever you think. And I know Peter and others from the steering committee are on, and yeah, please, whatever you think would help.
Peter, unmuted.
Yeah, Rainer, if I may add here, so this is Peter, if I may add something. So I was active in RDA as well, as you know, and what I see in RDA is a big, how to say, advantage is that RDA organizes a huge community, and it's a great platform for interaction and also fighting on the standards and terms and so forth. So I see this as complementary, as Christine already put out. So FDO Forum is only working on these FDO specifications, and will, together with you, Rainer, and the group, work also on disseminating implementation aspects. We will see how we can manage to do this collaboratively. But all the specifications which we will come up with, and we have first documents which will be offered to the registered community just the next days. All these documents which we have should also be made available and heavily discussed by the RDA community to really make sure that we, how to say, that all the specifications are really, how to say, meeting the needs of the community. I hope clear enough.
Thank you very much, Peter. Other questions, other comments? So
There's one in the chat, Rainer.
Oh, where?
I slowly typed
Sophie
an
asked,
answer, but yes, go ahead.
Sophie asked, how do the FDO forum working groups work? What are the activities, objectives, etc.?
Maybe I add something, since I'm also co-chair of one working group. The working groups are organized a bit different, depending on the working groups. Let me say we have three, at this moment, we have three core working groups. Let me call them so. And this is, you have seen that on Christine's slide. And these working groups, these core working groups that are really driving the specifications, they are meeting every month. And the requirements of these core working groups for participation are at this moment, I think, the same for all three groups. People should be involved in some concrete work on FDOs, and they need to have time, since we're producing a lot of specification documents, driving the specifications, I should better say, and you need time to be able to participate, to read, to comment, and so forth. So this is how we are working. Every month we have a meeting. We just had, as Christine mentioned, a meeting together with all three groups last week on FDO typing, which is a topic which is covering all three working groups. So we will see there may be more of these joint working groups meetings or so activities, but that's how we work. I hope it's kind of clear. So participation, everyone is welcome, and all specifications are made public at a certain moment. We have a process document now out there, and membership is bound to people, I guess, who are active in some way in the FDO work, either implementing something, planning something, and who have time enough. I think that's the basis.
Yeah, and if I could just add, I would encourage people to go to the website, look at the different descriptions. Feel free to contact one of the co-chairs for that working group, especially if you have something that you're working on through another project where you feel like fair digital objects could be an answer, or maybe you have something to contribute. Certainly talk to them. If you're not sure how you would get involved, then mark your calendars. Come to our January 19th event to hear more, and then make sure that you come to our next community meeting sometime in the early spring, where you can hear report outs from each of the working groups.
Mm-hmm. Thank you very much.
Yeah.
Definitely.
Rainer, maybe one other sentence.
Just a moment. Just a moment.
Oh,
definitely, we will bridge the activities of the Fair Digital Object Forum and RDA in this interest group. And we will also share the information. This is something which is important. We will have it open and transparent. So, Peter, sorry for interrupting.
Just to add one thing, so everyone who is interested in getting information and documents, and so at an early stage should just register, and then you are part of what we call the FDO community, right? So you will get information at a very early point in time.
Well, thanks a lot. Thanks a lot again, Christine, for your great presentation. And now I would like to switch to a kind of a working session. So now I'm sharing my slides again. Now we will go into short teasers showing FDO use cases and the benefits of fair digital objects. These will be really, really short teasers. And I would like to ask also all contributors or those presenters to summarize the benefits of using fair digital objects in their use cases, also maybe in one short statement or in the chat. In the collaborative notes. I'm sorry. And since this is a working session, if you see all the also everybody of the audience is asked, if you see certain contributions and certain benefits, please also add them into the collaborative notes under the correspondent title. So now I would like to ask Yvonne Anders to present her use case from the Earth system science. Yvonne, please.
Yeah, hi. So my name is Yvonne, and me and my colleagues, we are working at the German Climate Computing Center, the DCRZ, and I'm presenting an FDO use case from Earth System Science, as Rainer said. Next slide, please. And the DCRZ is not only providing high performance computing to climate modelers, it also holds petabytes of climate data published with DOI via the World Data Center for Climate, for example. Next slide, please. Actually, this is also the story. It's about reusing published data. We tried out whether it is possible to use just the DOI together with some additional information you can, for example, find in the publication to find and analyze the right files, the right files without touching by hand. So just the machine, is it possible that just the machine finds the right files and analyze it? Next slide, please. So for this, we wrote in a plugin and used a tool, but I would like to more concentrate on the data we used, because this is actually the for the digital object we focus here. So we used the CMIP6 data. CMIP6, for those who are not familiar with climate science, for example, it's CMIP6 is the most important climate model data at the moment and in the world, and it's used for the analyzing possible future climate changes at the moment. So it is very important. It's a very large data set. And it takes a while to create such data. It takes a few years. And this data is standardized according to a certain specification, which have been made in this CMIP6 community. And the file format is netcdf with some climate and forecast conventions. It's very important to mention it also in the context of FDO, because netcdf comes with a lot of metadata in the files. So it's very interesting for the machine to read this information out of the files directly. It's also important to say how the CMIP data is organized in this way. We have different levels. We have a DOI, which is given for the experiment or dataset group level. And each of these experiments consists of different datasets. And each dataset has a PID. Each dataset itself, again, consists of different files. It can be few, it can be many. And each file, again, has a PID for the files. Next slide, please. To just give an example, if you have one experiment, it can have, for example, 6,500 datasets. And if you think about maybe a mean number of files per dataset of 20, for example, it can end up with 130,000 files just to connect it to just one DOI. But for an analysis, or the researcher would like to do without touching it by hand, we only need 4 out of this one. Okay, next slide, please. So we have, as I said, the dataset level has a PID and the files has a PID, and the PID profiles are a little bit different. Next slide, please. I don't want to go into detail. If you have questions, you can ask me. And so what we learned actually here is, so I said we have this different level DOI for the experiments, PIDs for the datasets and the files. And we recognize there's actually a need at the moment to connect the DOI to the PIDs via the profile, but the community, CMIP6 community, is working on it, that there's some entry that what PIDs of the data sets are belonging to this UI. What is also very important is that it needs some standards and registries for the PID profiles, for the data sets, but also for the files. I showed that there are, at the moment, it's different and there are not really standards at the moment. For the machine, it would also be very important to know what kind of data it is. So the file, so the data type registry would be needed, so that the machine, for example, finds in the PID profile of the file, okay, this is climate data, for example, and then knows, okay, climate data comes usually with longitude, latitude, timestamp, a variable, and it comes in, for example, netcdf, and then it understands how to use this data. What we also recognized is that there is a limitation for the PID record lengths. There was a recent case that we had a researcher wanted to publish something, a data set which had 15,000 files directly connected, and another case 25,000 files. And if you think about that, the PID of the data set has this entry, has parts. In case of 25,000 files connected is just too long. It's not possible to handle such a PID record with this length. If you want to know more about, you can contact me or my colleagues you might recognize in the first slide, or you can view the presentation of the SciDataCon, and I put here the link. Thank you.
Thank you, Yvonne. Later on in the discussions, I would like to ask you also to summarize just in one sentence a bit. Let's go over to Stian. Stian will present about computational workflows as fair digital objects. Stian.
Thank you. So we're working on something called Workflow Hub, which is a repository of computational workflows. So it's a very particularly targeting life sciences, where people deposit the workflow definitions in these languages like Galaxy, Nextflow, SnakeMake. There's like 100 different workflow languages, but we have support for all of these particularly, but you can use any of them. Next slide, please. So here's an example of one workflow that someone has deposited. Is someone from Australia who deposited this one. So already spreading outside the EU. So here you see how the kind of description of the workflow is deposited in here. And if you click for the animation, you see that the buttons on the top here, the workflows are, no, just one click, please. Workflows are kind of active objects. Yeah, you can go to that slide next now. So you can run the workflow, that's a crucial thing. So to do some analysis, in this case, some genomics, in which case it wakes up and you have to fill in all the data and so on. Now we're going to a totally different server because they depend on the workflow system, what you need to use. So Galaxy have several public instances hosted by Elixir, like this use Galaxy. Now notice, and this is kind of how it is today, not how we want it to be, right? So you see now we are using something called the TRS Api from Global Alliance for Genomics and Health. And you can see this URL is kind of baked in some of our identifiers in there. And it's not PIDs, right? It's just broken apart a bit. So ideally, kind of all the middle bit there should just turn into DOIs. Because we do assign DOIs to the workflows, but only after people have kind of verified the descriptions and so on are the way they are. So that's one challenge we have, and that not all workflows have DOIs at the moment, because once we register them with DataCite, certain aspects of it have to freeze, right? And which is also why we have versioning of them. Next slide, please. So here you see the other button. If you download it, you get, this is the project I'm working on, our Create, which is where you download the workflow, but you also get the metadata with it. So you see here, the black bit is the JSON file, which will have all of the metadata you saw in the website. So it comes along with the GA file, which is, in this case, is the Galaxy file. Some workflow systems have many files, which is why this comes together as an archive. That's another reason why we had to use this TRS API, is because there could be multiple files you need in order to run the workflow. And they could be referenced with relative links and horrible things like that. So we cannot change every workflow system to to load up workflows all in one go, there might be that they need to have a folder structure so that carry along with it. So here you see the metadata rendered using other arrow crate tools. So we showing here how the metadata is accessible in many different ways. Next, please. So this is what I really want to talk today, is about one kind of use case that brings together all of these things. So the workflow itself is the kind of gray box in the middle that says Galaxy, which can come in an arrow crate and be a digital object, assuming you have clicked the buttons to make a DOI and so on. But also in this case, we are combining different types of digital objects, right? Because this is called a specimen data refinery, where we take samples of real-life specimens that live in museums and so on, that have been digitized already. So this herbarium sheet, for instance, often these things have lots of annotations and labels and so on. And we want to run these through a workflow to get out the text so that we can enrich the metadata of that. So it doesn't just say scan on the 15th of August on shelf 15, but we want to see who was it that collected this 200 years ago and all these kind of things. So we're combining lots of different tools, some AI, some OCR and so on. And there you see how it doesn't start as a digital object. It will come just as an image, maybe coming straight from the machines. So, but as soon as you are in the workflow, you start making digital object, and that's what's being passed along with the different tools. And in the end, you get an enriched digital object coming out that is then registered in Disco, which is a big community for all things natural science collections. But we're also collecting the history of this workflow itself. So maybe you saw in the Galaxy before, it had this kind of history on the side, and then here we export that as an arrow crate as well. So we're minting new digital objects that says how did this other digital object come to be, and there you will have references to all the other things like what came in and which workflows and so on. So that's pretty much it for me. Oh, one thing. The tools themselves, that's one thing we're experimenting with as well. Can we make the computational tools themselves also a digital object? Because then you can use them in many different workflow systems and not just in one particular one like here.
Stian, thank you very much. Now we're jumping to material science and engineering with Rosella and Zachary.
Hi, I'm Zachary Trott, and I'm presenting with Rosella Afrasella. So we're in the very early stages of development of how the material science and engineering community can leverage fair digital objects. And for those of you who are not familiar with materials, what I mean by that is the advanced technological world that we live in today is brought to you by materials, where there would be no skyscrapers without steel girders, no commercial aviation industry without high strength aluminum and polymer composites. And the statements can go on and on for the different technologies that we use with our mobile phones and solar electricity and modern medicine. Next slide. So material science is quite complex, and on the bottom I'm showing over time a scientist or a robot scientist goes into the lab and synthesizes a new material that they think will outperform other materials. And this material may undergo many different processing steps at multiple instruments before the scientist is ready to measure that material. And when they are ready to measure that material, they will take that material to multiple instruments, which will make different kinds of observations. And even under some observations, the material can change or experience damage just because of the way the instrument works. So if we want to think about digital objects for data sets or calibration for instruments, we also are thinking about what does a digital twin mean for material that undergoes change over time and visits many different instruments, and what is a digital twin of an instrument? So these are the kinds of concepts that we're starting to think about, and this is a graphical representation of one way to think about the types of digital objects and digital twins that we need, and the fact that they have relationships among them. Next slide, and I'll pass to Rossella.
Thank you. Okay, so from now on, I'm taking over, and I would like to give you a graphical example, a visual example of how an experiment in correlative characterization works. What you see here is a sample of a beautiful butterfly called Greta Otto. Next, please. Okay. Now what you see is that on the very same spot on the sample, the experiment consists of different measurements taken using different techniques. From left to the right, you have optical spectroscopy, scanning electron microscopy, white light interferometry, atomic force microscopy, and time of flight secondary ion mass. In particular, this last one is obtained having summing up different images taken at different times. Looking at this example, what is very, very clear is that in correlative characterization, you have to combine different types of information taken using different instruments and having different coordinate system. Across different length scale, you see I put on the bottom of the images an idea of what is the length scale of the images, and you see they are different. And at different times, in particular with the time of flight. Next, please. Okay, as already said by Zachary, in order to combine this data and to favor the exchange of data, fair digital objects are essential in material science and engineering. Motivated by this, Zachary and I started a coordination effort among the projects in which we are directly involved. Of course, those that you see on the slides are not the complete landscape in material science. It's just the projects in which we are directly involved, and we are trying a coordination effort among them. So in particular in the US, the NIST, so the National Institute of Standards and Technology, and MARDA, the Materials Research Data Alliance. From the Germany side, we have the Joint Lab MDMC, so Integrated Model and Data-Driven Materials Characterization, which is focused on correlative characterization and is part of the Helmholtz Association, and the NFDI Mathwerk, which is part of the National Research Data Infrastructure. At the European level, we have the NEP, which is the Nanoscience Foundries and Fine Analysis Europe pilot, focused on nanoscience, on multiple experiments joined together on nanoscience. And we also started an RDA BOF session on metadata for data indexing and data discovery in material science and engineering. And this effort has been organized together with our colleagues at NIMS, so the National Institute for Material Science in Japan. And if you're interested, the BOF session will be today during breakout 8 at 4 p.m. UTC. Thank you.
Zachary, Rossella, thank you very much for this insight. Now we're going to a data infrastructure from the Chinese Academy of Sciences. I would like to ask Lori.
Thank you, Luna. Hello, everyone. My name is Xinchen. I think it's very hard for you to pronounce, so you can also call me Lori. Today, I will talk about the data infrastructure of Chinese Academy of Sciences, talk about the challenges, some progress, and some future work. So next, please, next slide. Oh, okay. We have been working on the data infrastructure for more than 30 years. We already have a set of data infrastructure, but we are facing some challenges and problems. From one hand, we want to help the researchers to make their data fair before we pay much more attention to the big scientific data, for example, the data from mega facilities and some other some observation stations, but the small research data from the daily research work has been overlooked. We develop some tools for those who can develop databases, but not for the researchers. So we want to do something for the researchers to to strengthen the data reusability. And on the other hand, we also have a big volume of data from multi-source, discipline. So we want to make this data or this data object work together. First, for the data, now some scattered data have been integrated, but they have been integrated to some big silos. We want to make them work together, link together as a network, and we hope the data can flow in the network and not besides data, some algorithms, some computation components, or some other creative works could also work across data centers. And to realize this, we should produce develop some infrastructures, operations. All these things should be trustworthy and transparent. Next slide. Okay, this is a sketch of what we are doing now. And now we have developed some repositories. Some are institutional repositories, some are disciplinary repositories, and we also developed a general repository called Science Data Bank. And so the digital objects could be deposited and managed in these repositories. And the rectangle above it, it's what we want to do in the future. And we also have a data center network in China Animal Sciences. We hope all the data from different disciplines can work together to make a linked data network, and all we can provide collaborative analysis in the network. And based on the network, we can provide some end value services. And to realize this, we provide some software to help the repositories of the data centers. For example, InstaDB and DataSpace are software for the institutes to manage, for the researchers to manage their data. It will be the basic unit in the network. And about two logos, PyFlow, which is open source, which is a software to produce or process data in the workflow. It's open source and is already be used for some domain. For example, it can used to it has been used for the microorganism data microorganism data center in China Animal Sciences. It helped to produce production for them. But all the component data or components in this system is identified with just with the UUID. It has not been it hasn't used the PID. And on the right side is some common components, and some of them have been developed and some should be optimized. And for example, for the registries, we also have a data PID. It supports the PID and CSTR, which is identifier in China, but it can resolve the PID. But it can resolve PID just to a loading page. We want to make it. We want to use the PID, use it to make all the we hope in future our computation network will use PID. And the next one, KSDMP, we have a registry platform for the data management plans. And the next one, research information catalog. We have similar platform, which is called resource registry system. It has been operated for more than 10 years, but it overlooked the semantic issues. So it is being developed now. We want to include some. We want it to be a knowledge hub to record all the projects, researchers, and some other main data of the whole network, and to strengthen the interoperability, we will provide some cross-worker to do some clearing and mapping. And on the right upper sides, we have already provided some software for security and evaluation. All these things are just a technical view. We should also do some work for the standards or strategies and some other things. And all this infrastructure should be federated, decentralized, open, transparent, and trustworthy. Okay, that's all.
Lori, thank you very much. Now we're jumping to energy, to a photovoltaic system. And first I have to excuse Rob Quick, our coach here, who can't be here today due to health reasons. So I will give over to Jan with the concept towards a fair photovoltaic system.
Yes, thank you, Rainer. Yeah, hi, I'm Jan, and yeah, I present you this concept. Next slide, please. Yeah, the idea came up when we were working for the energy lab at KIT Campus North. This is a big experimentation field where we can interconnect different energy facilities on a big switching matrix and do real-time measurements on real hardware. And of course, there will be much data created. So we have model data, we have measurement data there. And the idea is to have a big information system, the energy facility information system, where all this data is browsable, and researchers can reuse data already in the system and create new data for the system. And this data shall be used in research, so it's used in publications, and therefore the data should be fair. And we tried to model our first facility for the system, and therefore we choose to do it with our photovoltaic system on our rooftop. And we noticed that we have two types of data there. So we have static data, which doesn't change frequently. This is on the one hand, the compositional construction data. So which entities the PV system is built with and how are these entities connected with each other. And we have the master data, which is mostly device properties of individual entities and vendor information, operating limits. And we have, on the other hand, the dynamic data, which does change frequently, and it's mostly measurement data of different quantities in the whole system. But one problem we have is that this data is already described in several different standards and schemes. Next slide, please. So here we see an exemplary PV system, and we are talking only about the inverter. So the device properties of the inverter and the operation limits are described with IEC 61850. So we see there's a maximum power output of 15,000 wattage and a maximum input of the PV array of 1,000 volts. But there's also some kind of positional coordinates in space. So we describe these coordinates with GeoJSON. Then we have the structural description, where we use an ontology to describe that the inverter exists and how the inverter is connected in the whole system. And we have the measurement data, which is described in sensor ML. And now the idea is, how can we connect measurement data and the master data bubble there to the structural composition? And next slide, please. There we came up with this concept. So the yellow-orange rectangle is the structural description of the whole PV system. And this is some kind of ground truth, because everything that is modeled in this yellow rectangle does exist. And the interconnection is described as well. there. And in the lower part of the picture, there we have the blue boxes, and the blue boxes is data described in several standards and corresponds mostly to an individual entity in the yellow rectangle. And we came up with the idea to use FDOs to bridge this, to link the data to the structural description. So on the left, in the left corner, we see an RDA collection about the inverter, and this collection bundles all information about the inverter. So we have the IEC information, we have the sensor ML information, the GeoJSON information bundled in the collection. The collection is referenced through the FDO 986, and yeah, and that's the data package about the inverter. And then we have the yellow rectangle, which is referenced through FDO 449. And to bridge those both worlds together, we create another FDO, the FDO 0815. And there we use, let's say, two techniques. One is that we use the Helmholtz metadata collaboration kernel information profile, which is an extension of the RDR kernel information profile and has the field has metadata. And has metadata field states that there is more data about the object. So we reference with the has metadata field RDA collection. And the object location of this FDO uses fragment identifiers to reference the inverter directly. So we reference the FDO 449, and the fragment identifies that we are talking about the inverter in this structural description. And yeah, to make the picture complete, we also have the FDO 42, which is some kind of single entries to the whole system. So if I want to reference the whole system with all data about it, I could only reference FDO 42. This points to a collection, and the collection contains all the other FDOs that belongs to the system. Yeah, that's the idea how we could make our photovoltaic or our energy facilities fair digital objects.
Jan, thank you very much. Now I'd like to switch over to, oh, sorry.
No, that's okay. It's just a summary of what I said.
Okay, good to have it. Now I would like to switch to a different use case from the humanities and ask Andreas to give it.
Yeah, hello. I'm going to introduce to you how we are applying the FDO concept to a humanities use case. Next slide, please. This use case involves Aristoteles manuscripts. Those are around 150 manuscripts, over 4,000 pages overall, and with over 35,000 annotations. So the idea behind this is to examine the process of knowledge change over time using these documents. And to do this, this requires insights into the components of these pages. So what is such a component? Next slide, please. What you see here is one of those pages, and those boxes are annotations. They are the result of an automated layout recognition. And on this data, this is what scientists see when they try to collaborate on doing annotations on those pages. So they can correct those annotations, add information to annotations, and add new annotations. For example, they could draw a rectangle or another polygon around the drawing on the right middle side and classify it. Yes, thank you. Next slide, please. Yes, to compose, to draw this image for an application, it needs two components. On the one hand, it needs the actual page image file. And on the other hand, it needs data to draw the annotations. And there are multiple ways in the infrastructure the researchers use to retrieve this information. One possibility is to get one file per page. with all annotations that are on this page. So to apply the FDO concept on that, next slide. Yeah, thank you. We can register a PID of the image, and below the PID box, you can see record information, a small selection of our record information. So we use a profile to ensure and what has to be in this record and what may be in this record. We have a location to the file, in our case, simply a URL. And we have a type, so the application knows what kind of file this is. Next slide, please. We also have a connection from this PID record to the PID of the annotation data. So there's the same profile in this PID record. We also have a URL to this, in this case, JSON file, and we have a type, so the application knows what to expect behind this file. Next slide, please. We also have a pointer back. So if you would give either of those PIDs to an application, it would be able to retrieve all information and draw the image. We also have, like I already said, additional information in there. This is just a selection, like versioning number, licenses are really important in this use case. And yes, so next slide, please. This use case benefits especially from having actual global identifiers that will not change when the underlying infrastructure changes, so we can involve the actual infrastructure underneath. And it benefits from being able to connect data outside of applications or independent of the location, the infrastructure, the type, or anything else. And we use our testbed, our fair digital object ecosystem testbed, to test and improve this concept in a sandbox environment. So this way we can at first create sandbox PIDs that are not globally resolvable, and retry until we think it fits, and then connect a real PID system to our testbed to actually publish it. We also have a poster to that in case you're interested, or directly take a look into the software. Thank you very much.
Andreas, thank you very much. And you already did it. You summarized your talk with a short statement, which summarizes the most benefit. This is also something before starting now the discussion, I would like also to ask all the other speakers to give a short statement or a short sentence. What is the main benefit of using an FDO? Yvonne, could you start?
Yes, and I wrote it already in the collaborative notes that that we in the climate science, we deal with topics like working with very large data sets. This one I presented is several petabytes large, many millions of files. We have to deal with server-side analysis because of this a lot, also reproducibility of the results, and interdisciplinarity. Also there's FDO very important, and also machine learning. So FDO plays a big role here, and especially in reproducible workflows, we need this. Okay.
Thanks, Yvonne. Great. Stian, would you like to?
Okay, so we found the formalization of how you can activate a resource is important, right? Because I showed you we have many ways to kind of wake up things like a workflow. And just the insistence in the sense of persistence identifier, which is very good for reproducibility and citability and all the kind of research software side of it, considering workflows as software. And the thing about data always coming along with the metadata. That's very important, so you don't lose that. But all of these things come with challenges as well, right? Like, for instance, we don't know when is an entry mature enough that we can actually register the PID and lock down some of the metadata. How do we do relative links when we have lots of things? And how can we preserve these active objects when our repository runs out of funding in, let's say, 30 years' time, right? But make sure the objects themselves stay perhaps dormant in some kind of archive. So we're trying to package them up and deposit them as binary blobs, but then the metadata as well should still be carried along.
Thanks, Dian. Rosetta, Zach, one short statement.
So this is Zach. I hope you also ask Marcella. So I would say machine actionability to the point and to the future of enabling autonomous, automated, and self-driving laboratories.
Thanks a lot.
Yeah. In case
Lori.
I would also ask, I will also add, sorry, that for reproducibility, as it was already said, plus data exchange and combination and interoperability. Thank you.
Sorry for interrupting. Thanks, Ross. Lori, do you have a short statement?
Okay, we have many different many data from different disciplinaries, and we also have some other data objects, something like computing components or some algorithms. We hope they can to be exchanged and work together. And I think they FDO a good solution for to be a universal description and the encapsulation of the multidisciplinary data.
Thank you very much, Lori. Jan, do you like to summarize?
Yes, maybe I could say the concept allows to use the standard and schemes which best fit to model a system without making assumptions, and FTOs and RDA collections are used to bundle informations and connect them to the entities where the information belongs to.
Thanks a lot. And last but not least, Andreas.
Sorry. I think I already said it more or less. So yeah, we benefit, highly benefit from identifying globally and abstract from our infrastructure. And well, currently we, when developing applications, the applications are the ones connecting and making assumptions on our data. And I think moving this to the PID record really helps a lot to make this more interoperable.
Andreas, thanks a lot. So now we are open for discussions. Any questions, any comments, any good ideas for other use cases or other benefits we can see from using fair digital objects in other circumstances? Paula.
Hi, thank you. I wanted to talk about a different digital object, but it was mentioned tangentially, the research software as a digital object. And the benefit of making research software fair is for recognition in the research process, that it's also an outcome of research. And there's a lot of researchers who are spending a lot of time and effort developing these digital objects, and once they are recognized by making them fair, we can also enable findability and reusability of those research softwares, and other people can benefit by not reinventing the wheel and just reusing those objects.
Thanks a lot, Paula. Other contributions, other comments, questions? We had some discussion in the chat. I didn't follow the full chat, but one question came from Sarah. Sarah, do you would like to speak up?
Yeah, hi. So I was just wondering if the concept can be used, so having this persistent identifier, can it be used into tracking data? So for instance, we have infrastructures, we're producing a huge amount of data and sending it to the researchers, and then to be able to track how this data is used and or published later on. Would that fit in this realm or in this concept or not?
Any comments to that? Peter?
May I give a try?
Yep.
Yeah, so basically you have two options or two ways, right? So one of the big advantages of fair digital objects is that they bundle all relevant information of data together, but not only data of digital objects together, which you need to have when you do searches and want to find things, want to reuse things, and so forth. So, and then you have two levels, basically, where you can build services on. One is the level of PIDs, whatever the PID is. The PID should be associated with some elements, attributes, and there is a certain degree of freedom, what kind of attributes you will use. They will be standardized. And then you have, of course, one of the elements in this PID record should at least point to metadata, and metadata can be various, as we all know. So the first possibility you have is do a search on the PID attributes, which you get when you resolve a PID. So believe or think about the following situation. You're using checksums of some form and add this checksum into the PID record. You resolve the PID, get the checksum, and you can already start doing some searches with this checksum. And there are other options dependent on the attribute set you're using. And of course, you will get then, and that's the normal way, you will get then the access to the metadata. And you can build machines then, of course, that work on metadata profiles to find something. Mm-hmm. I don't know whether this is complete enough, Rainer, but that's my try.
Thanks a lot. Lori.
Thank you. I want to add some comments and share a use case from our group. And we tried to do to build a system based on the blockchain technique, and we will record the PID and the signature of the whole object. It's something like the checksum, but it has some more information in it. And when we do some operation, for example, we will if we register FDO or we do a computation, we will record the ID and the PID and the signature in the chain. And I think it will be a solution to track data and with FDO. That's all.
Thanks a lot, Lori. Other comments?
Maybe I should add here, Rainer, that the industry is very much interested, of course, in making contracts on data. And the industry, therefore, is very much interested to add to the PID record an attribute which is a pointer to a blockchain entry. I will not discuss now whether blockchain are optimal ways to do things, but the industry is very much interested to have such an attribute.
Mm-hmm. Whether it's blockchain or another method or another technology, I think fair digital objects are invariant of the technology in behind. So we can use all the technologies. Heinrich.
Yes, here's Heinrich from DKC. So I'm very interested in the aspect of to make data of a digital object actionable. So I'm wonder what is needed to make a data actionable. So you have as well to put, for example, if I think on our data, so we have the climate data, and then you have to as well to store or to have the software which can be applied to the data. So within the fair digital object, there will be as well then stated or stored that you can, for example, use the climate, the CDOs, the climate data operators, and so on, or how the FDOs can be made actionable. So it's a quite general question.
So one possibility could be to use the canonical workflows with fair digital objects, which are also a topic in the fair digital object forum. Peter.
Well, Heinrich, your question is very up to date. So we just had last week a meeting, as I said, across all the working groups to discuss about typing. And what does typing mean? I mean, you all know the MIME types. They are restricted, but we need, it's very clear that we need a typing system for FDOs. So if you want to participate in this discussion, please become involved in this discussion. Well, what is clear is that if you want to make your FDOs machine actionable, that means if you have a bit sequence of an FDO and you want to, and machines should know then what to do on this, you first need to do strict typing in that sense that you need to associate the FDO with a type, as kind of similar as MIME types do it. But we need, of course, much more flexibility in the research domain. And then you need, and so a type is not sufficient, as we know. I mean, it's just as MIME types. You use MIME types, but in your browser or in your operating system, depends a bit, you make the link between a MIME type and an operation or a set of operations. So we need a register. So we have a MIME, we assume that we have a type. Every FDO has to have a type. And we assume that you enter, that there is a registry where you relate the types with some operations. And that makes you machine actionable. So the types have to be fair and the registries have to be fair, but you need this link as well.
Yeah.
That's our conviction at this moment.
Yeah, thank you.
Coming to the types, and Peter already draw a kind of a bridge. We were now talking about just the benefits and the advantages of using fair digital objects. But behind that is a long tail of things we need to do. So we will have not only benefits, but there will be also drawbacks by growing complexity. What do you think? What are the drawbacks of using fair digital objects? This is just the last question I would like to put to discussion. Or if we try to balance the benefits with the drawbacks. Any opinions in this direction? Stian, you're unmuted.
Well, yeah, as always, there's a learning curve, right? That we find even just when trying to get people to structure their metadata, right? So that it is where we have to be careful about not making it seem kind of unachievable. And we've seen today examples of how it can be achievable, right? But that is why, you know, having this kind of, I think Peter's nodding along because we talked about this, about having the kind of tutorial and training material to show that kind of gradual step up of how little can you do to still become an FDO, right? So you don't have to go all bells and whistles right away.
Other comments? Peter.
Well, let me add just one thing, which is very much in the line of what Stian just said. So we must, we of course, we know that we have much data which is out there, which is not curated, which doesn't have metadata, and so forth, and so forth, and so forth. So there's a long way to get to this ideal world of fair digital objects. Let's be very honest. So we are working on a paper which we call demonstrator paper, and some of those presentations which you heard today will be in this demonstrator paper, and you will see that we have built one demonstrator where we adapted a non-fair repository, not completely fair repository, to make it available or accessible via DOIP. Well, you know, we need a lot of these kinds of adapters to get all this data which is out there, to get this into this FDO world, and that's a lot of work. Let's be very frank here.
Thanks a lot. Other comments and any other ideas? If not, how do we proceed from now? So in future, we will continue with our fair interest group of the Data Fabric or Fair Digital Object Forum, the Fair Digital Object Forum, and the new interest group, or the morphing interest group on Fair Digital Objects Fabric. We will continue with the project chairs, definitely. We will continue with these kinds of discussions. In one of the next project chairs, we would like to invite Jan to tell us more about the energy use case, and Yvonne talking about with the use case from Earth System Science. But also, if you have any other ideas, any other proposals, what to show in our project chairs, it will be welcome. Also, we will continue with this discussion about the benefits and use cases, and this is also something we have put into the collaborative notes. We are collecting other, and we called it, according to Maggie, others amazing super duper application ideas. If you have any, please fill it in, and we will try to discuss it in later sessions. Any other ideas, other comments? If not, then I would like to close this session. Thank you very much for all your contributions, thanking all the speakers and the audience and the discussions, and also all those guys, everybody who contributed to the notes. And at the end, I would like to challenge the platform. I would like to ask you, please switch on your camera, please unmute yourself, and give a big applause to RDA and the RDA Secretariat and the organizational board who organized this event, to all the contributors and all these discussions. Thank you very much. Bye-bye. Tschüss.
Bye.
Bye.
No, thanks.
Bye.